Welcome, everyone. You hear me okay? Mic working? Good? Great. Awesome. Welcome to my talk. My talk is on middleware, and middleware kind of a showdown, a variety of different things. Who am I? I am Chris Patterson. I am from the US. This is my second time in London, but the first time for an extended stay. My first time at NDC London, so it's been great. My various links are on there. I have a YouTube channel. I have a variety of different things. I do consulting, kind of have my own company now. But I'm probably most known in the .NET community for Mass Transit. Mass Transit is an open source project. It's I call it a distributed application framework. It's a message bus, a service bus that sits on top of a variety of different middleware platforms. And that's what I'm going to talk to you about today. I'm going to talk about the different options that are available, why you might choose one over the other, kind of share some application stories of why companies or teams may have picked a certain middleware platform over others, and kind of give you some guidance, give you some ideas when you're going to start using some messaging type solutions in your own applications. So links are on there. So I mentioned the word messaging, and I will say, I brought my daughter with me to London, and last night during the speaker dinner, or I guess it wasn't the speaker dinner, it was the party, she looked at my slide deck and said, "Dad, no." So this is the first of her modified slides. The first two were pretty much me, but everything you see from now on has been completely modified from what I originally created. So any of the color and decorations are completely from her, so pretty awesome. And now it's not all white text on a black background, which apparently isn't cool. So messaging, why would we use it? Who's been here all week? 3 days worth. This is the third day for a lot of you. Awesome. Yeah. So one thing I've noticed in some of the talks that I've attended is there were some good talks on like why you might build in kind of a modular monolith way. It seems like we're coming out of this microservices phase where, the hangover is really bad because we're deploying hundreds of applications and we have no way to tie them together and all of that. And messaging is definitely getting a lot more awareness, especially as more people pick up patterns. There's YouTubers that are talking about, clean architecture and messaging and mediators and message buses and all of this stuff is getting out there to where people are starting to think about it now, because for years and years, especially like the microservice culture, is this point-to-point integration culture. There's tons of HTTP, and even with Kubernetes or function-based deployments, it's tons of RPC. It's tons of just connections to different services and different endpoints. It's a lot of request responses, it's just a procedure call, but we're going out of process. So what used to be a nice, fast monolith with, assemblies loaded in process, and all the calls are quick because they're all in process, and things like memory and transfer size and response size didn't matter. Those things are becoming important because we're making calls to other systems. And in a lot of applications still, you're seeing a lot of point-to-point integration. And I've seen some slides throughout the talks this week where it's like the big ball of mud, the spaghetti, the lines going everywhere. And in one of the talks yesterday, it was like, how do we clean this up? And it was that idea of getting away from this RPC-based system into something that is a little more scalable and a little more resilient in the presence of failure. The challenges of RPC are pretty common. It's like you have to have 100% uptime. To scale, you have to use like load balancers, and things like Kubernetes and container apps and these other things have made that a little bit better, but it's still scaling up a lot of things and having things always available. And so when we move to a message-based integration, some of the benefits of that, we get asynchronous processing. We're running in a different system. We can move things out and take what was a modular monolith or a monolith and move bounded contexts outside of the application. And using messaging, we're able to do that in a way where we don't have to be fully available. The common example of message-based integration and some of the benefits are like ordering. I can accept an order and write that message into some piece of middleware, knowing that that is durable and reliable and can be picked up later so that my back-end fulfillment system doesn't have to be there. I can upgrade parts of my system and I can have partial availability because I'm not dependent upon the entire system being able to run at one time. Other benefits of message basing, you get scalability, load balancing is built in, You're able to scale out. Durability messaging, at least in the way I think of it, is always durable. It isn't like HTTP, where if the connection or client breaks, that transaction is lost, and I don't know whether it was or wasn't processed. I'm just, maybe I retry it. Poly is like all over these RPC systems, which is just a retry and exception handling framework to just constantly retry these RPC calls. With messaging, it's in the broker. I can handle that at the consumption level. So, does anybody not understand the difference between messaging and RPC? It's talked about a lot. So, but I'm not here to completely talk about messaging, even though I live mass transit every day of my life. I'm here to talk about middleware. And middleware is not the use things in ASP.NET that lets you add filters and stuff. Middleware it sits in the middle. You have service A and service B, and middleware is a piece of software that is running in our system that provides us this messaging capability. So when I think of middleware, I think of things like message brokers. I think of things like event logs, things like that. I'll get into that in the talk. So we talked about messaging, and middleware is kind of the disambiguation. We're talking about a piece of software that sits between two services. And with messaging in mind, I want to kind of just briefly touch on the different stereotypes of messages that there are. So when I think of message types, there's 3 different kind of primary message types in messaging. There are commands that are telling you something to do, like submit order, or process order, or cancel order. It's verb noun. It's like do to thing. And I think even in some of the early days of API design, it was like tell, don't ask. It's like do this, and if you don't do it, let me know. It's just like take out the trash. Did you take out the trash? I don't know. Well, yeah, you can find out. The other type is events, things that have happened. Events represent a change in state. So an event is telling something that happened. It's not saying something that might happen, although you could probably do a preemptive, I'm about to do something, but that's more of a notification. But events are like, hey, I accepted an order was submitted, a credit card was rejected, those type of things. And those are generally fire and forget. If I tell you to do something in a steady state system, I'm going to assume it's going to get done, and if it doesn't get done, some sort of processing in my system is going to handle it. Events are like, hey, I could just be saying things that happened, and I don't really care if people react or not. I could be in this room and I could yell fire, and all of you could run out, but if the people who didn't get it, well, maybe they won't run out. But it's a broadcast. I don't necessarily care who the consumers of it are, and that's an important distinction. The third type is really just it's kind of like a command event, but it's a pair, and it's used extensively in messaging despite I understand why, but I think it's because a lot of systems are expecting a response, but it's really like a command that expects a response back. So the event is that you pass me the ketchup when I tell you to pass me the ketchup. Of course, maybe I'm asking, please pass me the ketchup. Or here, lately, it's been, please pass me the malt vinegar, because I've had fish and chips 3 days in a row. It's kind of a thing. And apparently we're having it again today, so. And then, of course, the response comes back, here's the ketchup, or there's no ketchup available, because that's a thing. So those are the different type of messages, and that's going to be important when we start looking at the type of middleware that we're going to use in our systems. By the way, I love interruptions, so if you do have any questions or if anything I say is silly, kind of raise your hand, either come up to the mic or whatever, we'll definitely cover it. Or you can save it to the end. It's always good too. So when I think about middleware, I think about 2 different types of middleware. And I think of them as queues and streams. Queues are a word that I hear more in London than I ever hear in the US, because we call them lines there, and it's basically people waiting to get somewhere. Here, everything is a queue, so it's kind of funny. What is a queue? Queues contain messages that are consumed and removed. So when I think of a queue, it's like you get to the front of the queue, you do your thing, and then you're gone. So they are durable but ephemeral. And I'm talking about queues that are actually managed broker-based queues, not just a simple data structure like Q of T in .NET, or even something as kind of weird as Azure storage queues, because those really aren't managed, it's really just storage on a disk. So when I'm talking about queues, I'm talking about broker-based queues that maintain order. They are read from the queue and then consumed. Typically, they're read from the queue and then removed from the queue. And then when I talk about a broker, I'm talking about bits of functionality that actually happen in the broker. So for instance, what does a broker do? Beyond just saying keeping track of a series of messages in order, they enable a lot of message patterns. So things like just what I said, having a message at the front of the queue, removing it from the queue, or in many cases with many brokers, locking that message in basically saying, I know someone is consuming this message, that message is being consumed, and then it's either successfully consumed and removed from the queue, or maybe released so that something else can pick it up again and retry that processing due to failures. Different brokers have different capabilities. I'm going to kind of go over some of those so that you can understand why you might choose one over the other. Another capability the broker has is routing. The very basic concept of queuing is sending from point A to point B. You know the destination, you know where it's going, and that's great. That's just like that's just like RPC. I know the HTTP endpoint I have to call. I know the service name that I'm calling. But with messaging, you want to do some really cooler things. You want to do publish and subscribe. You want to be able to just say, I want someone to handle this, and I don't care who handles it, I just know someone has to handle it. And that dynamic discovery can be really useful for creating systems that are additive and flexible. So brokers typically have routing options, and I'll go over into some of the routing options that each of the broker offerings have, the cost of that, and the performance of that, and what that might mean. Again, brokers provide that message locking. They provide redelivery in the case of like a consumer crash, because that's one of the nice things about messaging is if I'm consuming a message and my process crashes because my consumption involves using all the RAM on the container and crashing the container and causing it to get recycled, the broker will make sure that someone else picks that up and processes it, and even after a number of tries might dead letter it or say, hey, this message is not processable, it's a poison message, I can't work on it, put it someplace so that operations can figure it out. So these are all things that I expect a broker to do for me. And again, that's above and beyond just reading from the front of a table in a database and assuming something is going to happen. And we'll cover that as well. Any questions on what a broker is? I think we're pretty good there. Great, awesome. So I'm going to start first with Amazon SQS, not because it just comes first in the alphabet, but because that's where it is. Amazon SQS Simple Queue Service. It is literally simple queuing. It is nothing fancy. It is used ubiquitously across AWS. It is used for a lot of their notifications, although that's also using SNS. And it scales really well. It scales out really well, and it's super cheap. There are some downsides to it. It is simple queues. There isn't any routing with SQS. So I can't do publish and subscribe with SQS alone. As I said, it's cheap. One of the limitations of SQS is that who's using AWS in production, dev, whatever? Okay, maybe 20%. SQS has accounts, and admittedly this has gotten better with organization and roles, and you can actually create sub-accounts and kind of have billable units now. They've kind of caught up with everybody else. But SQS is per account. So that can be a limitation for a lot of people because depending upon the way you name your queues and lay out your queues on the broker, it's one account. So if you're trying to have one AWS account, you're a small company and you want to do prod, non-prod, dev, and test all in the same account, you have to think about things like every queue has to have a name or like a prefix of like dev-orders. So you're really kind of struck into that with the per account. Now you can create multiple accounts in AWS, and I kind of highly recommend doing that, especially for prod and non-prod, but I've only been working with customers running AWS in production systems for about 2.5 years. Before that, it was mostly Azure. So my experience is limited there, so I certainly yield to others who might have more there. But I do know that the per account SQS, everything is shared, can be limiting, and a lot of times that can be a problem. Now I do run mass transit, and of course mass transit has support to say, okay, I want to prefix all my queues and all my subscriptions and everything and create these sub things. So it does work pretty well. But to do publish and subscribe and message routing, you can combine SNS, the simple notification service, with SQS. So that if you say, produce a message or publish a message through SNS, it can then route to multiple SQS queues. So you can simulate kind of a publish-subscribe environment using those two services in Amazon. At least that's how mass transit does it. SQS does have some cool features. It has the ability to do some things that I wish other brokers could do. First of all, you can delay delivery of a message in SQS. So it has kind of built-in scheduling per queue. So you don't need to run something like a Quartz or a Hangfire to schedule messages. So that's a nice feature. It also has delayed redelivery. So mass transit has a feature called delayed redelivery where it's like, I want to retry this, but I want to retry it in a minute, not a second. So mass transit can use the visibility delay to delay that message from appearing in the queue again. The cool thing about that is it stays in the original order. And SQS has the ability to group and sequence chunks of messages. So if you have like 100 related messages, you can give them the same group ID in SQS, and SQS will actually keep them in order and make sure they're consumed in order from start to finish within that group. So if you have like important ordering things, it's a great feature of SQS. I wish other brokers had that, but they don't. Those are FIFO queues, by the way, if you create your queues as FIFO. But the delayed redelivery is great because you can say, oh, I'm not ready for that batch yet, and it will hold that first message and not deliver any of the subsequent messages. So very cool stuff. So some limitations, but again, it's super cheap to use SQS. It's part of every Amazon account, and you can just create queues and just go all day long. So, but it does have some simplistic routing with the SNS topics. RabbitMQ. Anyone who's looked at download counts on mass transit knows RabbitMQ is the hugest deployed broker by mass transit. Who's using RabbitMQ? Anyone? Yeah, at least half the hands went up, yeah. So RabbitMQ is great. I really like RabbitMQ. It's an amazing transport. It has had certainly some detractors over a period of time. But now, I mean, it supports quorum queues. It supports a lot of reliability features. It's had a lot of modern rewrites. It's written in Erlang, which is pretty cool. It runs anywhere. I can run it in containers. I can run it in Kubernetes. I can technically run it in container apps, although there's some weird limitations there. And things like Cloud AMQP, I can just get somebody to run it for me, and I don't have to hire anybody to support it, which is fantastic. It's just as easy as other SaaS-based brokers. The great thing about RabbitMQ is it supports queues, exchanges, and bindings. And these bindings can be really complex. So you can do some really cool routing things to get really efficient message routing across RabbitMQ. As I said, Raft-based quorum queues. Raft is a like post-Paxos consensus agreement protocol where you ensure fast replication of data across multiple nodes. So if anyone's used the old RabbitMQ HA queues, they know that they're absolutely horrible. And Raft-based quorum queues are really awesome. So definitely some benefits there. As I said, you can run it anywhere. You can run it on-prem. You can run it technically on device. I mean, I know some people that are running it actually out in Edge because they're able to link it back to the parent one. Yeah, it runs anywhere. The container apps thing is weird. I guess the current version of container apps, you can only have a single port mapped from a container in container apps. So you can either manage it or use it, but you can't do both. It's kind of weird. So, but yeah, RabbitMQ is super fast. The exchange bindings are great because they have like topic and queue bindings that you can do like routing with routing keys, and you could technically have queues for every cash register in a retail system so that you could send messages back to each of those individual things. A lot of high-frequency trading systems use RabbitMQ in memory with non-durable queues because they're able to very fast fan-out updates. That's another use case. So, RabbitMQ, I mean, is it something that you want to grab for all the time? It generally, like I said, it works well. It's super fast. It can be deployed everywhere. I hate to say it's like the default option, but it's kind of the default option. I mean, if I was going to start queuing today, I would start with RabbitMQ because I can spin it up with Docker. I can spin it up with Aspire, which is like, apparently I don't want to do Docker Compose, so I'll do it in the .NET way thing. So it's great. I mean, I can't say enough good things about RabbitMQ. I've had tons of production systems going back 13 years running in RabbitMQ, so it's definitely shown some reliability. Azure Service Bus. Azure Service Bus is an interesting one. I mean, anybody deploying on Azure has probably at least tried to use Azure Service Bus at one point in time. It's very reliable, it's highly available, it has different tiers of capabilities, both basic, standard, and premium. And it has topics, queues, and subscriptions. What's interesting in a comparison of RabbitMQ is RabbitMQ, everything has to eventually end up on a queue. So even with exchange-based routing, it all eventually ends in a queue. Azure has this weird kind of hybrid concept where they have subscriptions on topics which act like queues, but aren't really queues, but mean you don't have to have a queue to consume from a topic. But they don't behave like queues and you can't actually interact with them like a queue. So they're kind of like queue-ish, but they can cause some issues because now all of your messages are sitting in the topic, all of your storage quotas are tied to that topic, and if you have a consumer that stops consuming from the topic, it can take down producing to the topic. So there's some weird things. Azure Service Bus definitely requires a lot more care and feeding. That said, it's very fast, it's very reliable, it runs in the cloud, it fits into your nice Azure subscription billing. It does have some cool capabilities. Similar to SQS, it has session-based message ordering. And the cool thing about that is actually that it has persistent state. So if you've used mass transit, how many people have used mass transit? I guess I didn't ask. Okay, maybe a third. Mass transit has stateful workflows or sagas, and those sagas are persistent and use a number of persistence mechanisms. With Azure, you can actually store sagas in session state using sagas, using session-based messaging. So it basically gives you a byte array that you can store, so you can actually store saga state in a session. And that's cool for when you have like a really lightweight saga that you don't want to tie a database to, like an Azure SQL or a Cosmos DB. So that's kind of a cool thing that you can do with session-based. Plus, sessions are ordered, they lock, and they deliver in order, so you can do in-order message processing with them. That said, they're Azure Service Bus specific, and they only work with Azure Service Bus, and Azure is cloud only. You can only work with it on the cloud, connected to the cloud, not on the airplane flying 9 hours from Texas to London. So, you know, we've heard stories and rumors of a potential of having some local testability option with Azure Service Bus. So far, nothing has happened there. In fact, a lot of people using mass transit will develop locally and test locally using RabbitMQ and then deploy using Azure Service Bus to their Azure environments. And since mass transit is an abstraction layer that sits on top of that, it just works. If you're using the standard capabilities of adding consumers and configuring endpoints and deploying your application to RabbitMQ, it deploys just the same, whether it's going to Azure Service Bus, RabbitMQ, or in most cases, Amazon SQS. And I say most cases. So mass transit, one of the things that it has is the ability to do polymorphic messaging when publishing. So if you're a typical C#, so mass transit, when you create messages in mass transit, they're classes, or now they're records. In fact, I only recommend people use records for messages now, because why not? They're cool, and they're in the language, finally. But you can we love to create message hierarchies. We need to have like a base, like I order message. And then I have, submit order, order process. I may have different messages that implement that I order message. With mass transit, when you publish one of those, in RabbitMQ or in Azure Service Bus, it creates a inheritance hierarchy in the exchanges or topics for those messages to be produced. So when you publish, you could just have a consumer of I order message that maybe does some audits. Maybe you have to do like an audit track for like SLAs of time to, like if an order goes idle without reaching a terminal state within 48 hours, did it die? Did something happen? Do we have to triage it? And so people will use this polymorphic messaging to produce messages and have consumers that just implement some of those. It works with RabbitMQ super fast. It works with Azure Service Bus reasonably fast. It does not work with SNS SQS. So something to think about there if you're going to use polymorphic messaging. I will say one thing about Azure Service Bus versus RabbitMQ in the decision support side there and why I prefer RabbitMQ for any type of complex publishing. As I stated, messages in RabbitMQ always have to end up in queues. So even when you create the most complex exchange-based routing fabric in RabbitMQ, it's always going to end up on a queue. With Azure Service Bus, you can do that also with topics, But what happens is topics, as I said, they can have a subscription on the topic where messages are consumed from the subscription, and in mass transit, that's called a subscription endpoint. By default, a receive endpoint, mass transit is going to create a subscription on that topic that forwards to the queue. And the reason that's important is because then no matter what messages are published, they get forwarded to the queue and that order is maintained by Azure Service Bus. The disadvantage of that is Azure Service Bus is going to charge you for writing to the topic, forwarding to the queue, and then reading from the queue. Now, in most cases and in most experiences that I've seen, that is not important. It's tenths of a hundredth of a cent. But if you're doing 100,000 messages an hour, it might make a difference. And I've actually seen some people that were doing pure just processing change to just using direct sends to queues rather than just publishing because the double hit was actually significant. But for most customers, I've never seen it actually become an issue. It's literally like, did we buy a pizza for the team today or we didn't? Because it's maybe 10 or 15 bucks a month difference. But it is something to keep in mind is that Azure charges for every little messaging operation. The other thing I would say about Azure Service Bus is if you're gonna run it in production, I'd highly recommend running a premium SKU. It's the only way you get guaranteed processing. It's the only way you get off SQL Server because Azure Service Bus Standard runs on top of Azure SQL. Azure Service Bus Premium actually runs on a completely different engine which scales significantly better. So you get much better guarantees and you also don't get the noisy neighbor throttling. A lot of times people say, well, we went to production and we're seeing weird delays because they're getting throttled by Azure because Standard has a lot of throttling in it. So the disadvantage of that is I think one MU in Azure Service Bus is $600 a month. The entry-level RabbitMQ Cloud MQP is $99, and it has the same message rates. And they will deploy it into your cloud region. And they will actually private peer it if you want them to into your subscription. So again, it goes back to RabbitMQ is usually the right choice, but there's certainly reasons to use Azure Service Bus. Azure Service Bus integrates better with a lot of other Azure services. So if you're doing things like Azure Functions, Azure Workflows, things like that, they're able to consume better from Azure Service Bus than others. Those are probably the two most sophisticated brokers out there. I mean, they do a lot of things. I mentioned ActiveMQ, and this is by far the least used in the .NET space. It's a lot of times people are interoperating with a Java team. Yeah, I mean, there's various versions of ActiveMQ. It's certainly supported. We continue to support it and update it. They finally updated the ActiveMQ.NET SDK about a year ago. Before it had been like abandonware for 3 years. So it's definitely there. It has some capabilities. Like I said, it's a lot of times when people are integrating with Java teams. I certainly, if I was a .NET engineer, I would never pick RabbitMQ as my broker. Now, the thing is, Amazon offers 2 queuing services in Amazon MQ. They offer ActiveMQ, which is the original, and then they also offer RabbitMQ. So Amazon MQ, you can pick RabbitMQ, but it's a limited version of RabbitMQ in the fact that they don't yet have support for quorum queues. But again, Cloud AMQP can deploy into your Amazon as well. So, and I'm not advertising for Cloud AMQP. It sounds like I am. I just know it's brain dead easy to use them, and they're super cheap. So, you know, Drew Sellers, the co-founder of Mass Transit, runs his message aid platform on Cloud AMQP because it's just brain dead to run it. You don't have to think about it. So queues, we can't talk about queuing without talking about SQL. How many people have tried to build their own queuing job scheduling delay system in SQL Server? Yes. So finally, about 6 months ago, created a SQL transport for Mass Transit because I've been in application development longer than I can think. And we've always, I mean, even before there were queuing systems, we were writing stuff to ISAM tables to process and consume data. There's a lot of homegrown solutions out there. You'll read one blog post that'll say, never use a database as a queue, and then the next day you'll read one saying, wow, Postgres can process 3,000 messages a second as a queue without any fragmentation. And you're like, okay, so what have they done? I think that the thing for a lot of people is that they have databases in their application already. They're used to writing transactional code. And bringing in another dependency, especially one that has to have all the nines of availability, because when you start doing messaging, its availability is equally as important as like your database. In fact, more so if your application is architected message first. So a lot of times people will be like, well, I really just want to use my database. Or they might have transactional applications that don't want to talk about messaging, but need to produce messages out to a system. So I did finally create a SQL transport. It supports Postgres and SQL Server. The numbers aren't bad. I mean, Postgres is a copyright, so copy on modify. So if you modify a page, it creates a new page, deletes the old page. So there's like a lot of vacuuming. And yes, the databases have gotten much faster. But it seems to run pretty well. You know, I've always said, and I will still say, if you can use RabbitMQ or something like Azure Service Bus, it's probably a better option. But this is a great choice for people to be able to do it. It's still early. It's in pre-release. You can pull it down and use it today. I'm definitely looking for feedback on it. Because I love RabbitMQ so much, I built my SQL transport to work like RabbitMQ. So it supports routing keys, direct exchanges, topic exchanges, all the cool stuff that you get with RabbitMQ, it supports in the SQL transport. And I support it in memory too, so it's awesome. And so message brokers are basically like, give me the first message, okay, thank you. Or in the case of like partitioning and routing, it's like, oh yeah, give me messages in this partition. Let me lock that partition or that session ID. SQL has these awesome partition over kind of query things that lets you do some wild stuff with window functions. And so like delivery modes inside the SQL transport include things like, okay, well, I want you to give me up to 100 messages, up to as many partitions as you want. Just give me the first message of each partition so that I can maintain order, or give me like up to 10 messages of each partition. So you can do some really cool things with window functions in SQL and locking. And so I did it, because why not? I liked writing SQL. It was actually kind of fun for a while. So yeah, it's definitely an option out there. Try it out if you're using mass transit or need to use SQL and are using Postgres or SQL Server or Azure SQL. It's fast enough for most people. I mean, it's hundreds of messages per second on SQL Server and thousands on Postgres. But yeah, it's definitely an option to do. We also have kind of this hybrid world. So, and you see this a lot. You'll see this on some of the YouTubers. They'll talk about, you know, everybody's talking about an outbox, or I need an outbox, or I need an inbox or an outbox. And when you think about what an outbox is, you're providing messaging semantics to something not talking to a broker within the context of a transaction, such that you can take those messages from that transaction or those events produced from that transaction and give them to a broker. So Mass Transit supports an outbox. It supports it with like Entity Framework and MongoDB. And I think of it as like this hybrid approach, because I can actually write database-oriented code using a DB context, produce events using mass transit primitives, but not actually have a connection to the broker. I'm only talking to the database. And then another delivery service is then reading those messages out of those outbox tables and writing them to the broker in a reliable, consistent way to ensure that they get delivered to the broker properly and in order that they were produced and all of that, with consistent message identifiers, so that any retry or processing of the transaction doesn't cause weirdness downstream. So that's kind of a hybrid between like SQL and a broker, because I'm able to do SQL type work, but yet I get my messages to either publish or send directly to a queue so that I can consume that data elsewhere in a message-based system. So that's kind of a nice bridge that can get older systems into that. So to sum up queues and kind of queues in general, these are for dispatch, these are for consumption, these are for things like I'm telling you to do something, and once you've done it, I'm not going to tell anybody else to do it again. I don't need to know about it. It's commands, it's events, it's request response. All of those things use queues, and queues are good for that. And those are a number of the brokers that, and kind of the benefits and capabilities of each one. So now I'm going to jump over and talk a little bit about streams. And streams are awesome with an apple tree. Yeah, awesome. And for streams, there's really two major players that I'm going to talk about, because I've found that these are kind of the dominant ones, and one is significantly more dominant than the other. And so I wanted to make sure that I covered that. So Apache Kafka. Who has used Kafka? Less people than I thought, really. Okay, interesting. Either people are shy or, who knows. Kafka has definitely, over the past probably 9 years, grown from like an Apache project to like a fully managed company with Confluent Cloud that does full PaaS operational runtime monitoring of your Kafka cluster, all your updating, all your permissions, all your management, all your dashboards. You don't have to hire a Linux expert that knows how to run. I think Kafka used to run as like a Yarn job on top of Hadoop, and I don't mean like Yarn, the opposite of NPM. I mean like Yarn, the scheduler that's on Hadoop, which I don't even think anybody uses Hadoop anymore. It's like I never hear it, so who knows. There are ways, but the nice thing about Kafka is it is open source. It is an Apache project, so you could run it yourself if you were a glutton for punishment, because it is a pain to keep a cluster up and running. If anybody who's used Kafka knows the pains of the first few years of Kafka, it was an absolute nightmare, especially when you start bringing in storage options. But yeah, so Kafka is definitely a great option for, and why would you use Kafka? This is for events. And as Oscar may have told you yesterday, Kafka is not an event sourcing platform. And I think you're going to find out later today, if you go to Ian Cooper's talk, he's going to talk about Kafka for .NET developers. So definitely a deeper dive into Kafka there. The thing that is great about Kafka is that it is extremely fast for intake. And it's extremely fast for read. And Kafka, I don't call it a broker because even though they use like the broker moniker for it, it's really a log file with an API. Kafka is very, very good at being able to ingest and write and store data in a message-based format. Each message is like a block of bytes that can be JSON. It can be a number of different formats like protocol buffers or Avro. And it can span that out across multiple partitions. It can do a number of things, but it does it at incredibly high scale. And when I say high scale, we're talking easily 50,000 messages per partition per second. I mean, it is really, really fast. And so like IoT systems pulling in data, taking exhaust data out of other applications. So where I see this typically used the most is like big companies use a lot of off-the-shelf software. And a lot of this off-the-shelf software may take the place of order management systems, ERPs or enterprise resource plans, SAP, JD Edwards, all of these big things that they use to run their corporations. And the problem with those systems is they're usually very opaque in terms of the internal view, but almost all of them now have the ability to emit events. So like an ERP, like an SAP, can emit events that are like material movements, like this product went from the warehouse to a truck, or went from the truck to a warehouse, or went from one warehouse to another warehouse, or any of these logistics planning systems. And they're able to emit these events in this nasty, thick XML, which is just absolutely horrible. But the integration with those platforms, trying to do that, especially since most of these platforms are written in like Java or ABAP or any of these really crazy, weird languages, the integration with these platforms is not fun. And it's surprising how many of these companies need to do that, but they can't because it's so difficult. And so companies pull for things like MuleSoft, which MuleSoft is a part of Salesforce now. But if you go to any SAP or JD Edwards system and say, oh, we need to integrate with this, they say, oh, we recommend using our MuleSoft connector. But let's face it, if you're paying for SAP, MuleSoft is a drop in the bucket, because SAP is millions of dollars like a month, and MuleSoft is also expensive. MuleSoft used to be this tiny company, and then they like blew up and got big and met with everybody. So the challenge with these companies is a lot of times the EI or the enterprise integration teams, they only know like MuleSoft or some other connector type thing. And so what's happened is a lot of these larger off-the-shelf software solutions that run businesses are able to produce data. It's really easy to get that data into Kafka because it's highly available. It can handle any message data rate. And you're likely going to want to do multiple things with it. And you're never going to get it again because the ERP is never going to emit that event again and say, hey, guess what? This happened yesterday, but I'm just telling you again. So Kafka is great for this because you can set retention periods of like 6 months or a year. And you're able to reprocess and consume that from as many different what are called consumer groups as you want. So if you think of a consumer group as a sort of queue, and I've heard that they've got some preview code coming out where you can treat streams as queues, from Confluent, where you can basically create like a queue-type semantic on top of a stream. And really, it's just taking this idea of a consumer group, which is a thing in Kafka, and essentially a consumer group just says, for this partition, I've read up to number 27. For that partition, I've read up to number 13. All it does is keep pointers of how far you've consumed in the stream, because again, a stream is just a file from start to finish of a series of events that are running across the system. And they don't disappear. You're not consuming them. They stay in the stream so that you can reprocess that. You can always say, oh, I want to start from the front, or I want to read everything. And that makes it really easy to try some logic, change the logic, try it again, and process over a large data set versus waiting for new data to come in like you would do with a queue, because again, queues consume to 0. So the advantages of Kafka, obviously getting data into it from systems that are fairly opaque is definitely one of the reasons to use it. It is highly scalable, highly partitionable, highly available, and a lot of things work with Kafka. If you pull down a lot of different cloud-based solutions, they'll say, oh, you can connect to a Kafka source, pass it, and they know how to read from it, and they know those semantics. So it's really easy to go back later and say, okay, we've been exporting this data for 6 months. Let's go do like some streaming analytics on it. Or let's use, Kafka has a feature called KSQLDB, which lets you create virtual streams and virtual tables on top of streams, where you can query message data in a stream as if it were a database. And so there's some really cool capabilities there. Mass transit does support Kafka. You can consume and produce from Kafka, and it works really well. I mean, we've used this to pull data out of material movement systems coming out of SAP ERPs to track availability, to track lineage as far as where something has been. You know, did it get shipped correctly, things like that. So it's very well supported. I would never do command processing in Kafka. I would never send a command to a Kafka queue. Just like I would never send a request to a Kafka queue or a Kafka stream and expect someone to respond on another Kafka stream. When Kafka first started coming out, people were like, well, how do I do request response on Kafka? Well, you don't, because things are there forever. It would be weird. But I've had people say, well, I already have Kafka. Can I do requests over that? No, don't. Just literally don't. It's for emitting events. It's for emitting changes. Another nice thing you can connect to it is, as evil as it is, you can take CDC data capture. So change data capture, most databases support it, Postgres, MySQL, SQL Server, Azure SQL, and you can take those change data capture events, write them straight to Kafka, and you can use that to interpret or do data distribution to other systems. So you can like update front edge caches. I know companies that do this for updating data in all their regional sales centers because they keep an edge cache of like everything for them. And so they'll take those events out of Kafka and consume for them. So something similar to Kafka is Azure Event Hubs. Who's used Azure Event Hubs? Even less than Kafka, great, okay. I mean, Azure Event Hubs was Azure's answer to Kafka. It was written and built to be that. Within 6 months, they added a Kafka backwards compatible API so you could use Kafka clients to talk to Event Hub. So you get like the PaaS capabilities of Azure Event Hub, but you can use Kafka-based applications to talk to it. It is very similar. It does a lot of the same things, so you would use it in the same reasons you would use Kafka. So a lot of those overlap, which is why I don't really say too much about Azure Event Hubs. The disambiguation here is, though, this is not Azure Event Grid. So Azure Event Grid is like Microsoft's IoT, Mosquito type solution for all these rapid IoT events. Well, I mean, they originally said Event Hub, but like anything that happens in Azure, like a storage account created or any of those type things, that all goes through Azure Event Grid now, which almost makes it kind of like SQS was supposed to be, or maybe SNS, but yeah. So we're not talking about Event Grid, we're talking about Event Hubs. They do let you do like the partitioning, the consuming, the same things that you can do with Kafka. Again, Mass Transit has native support for Event Hubs. The API is surprisingly similar to the Kafka API. It just uses the Event Hub client directly instead of the Kafka API. You can actually point the Kafka client in Mass Transit to an Azure Event Hub if Kafka compatibility is enabled, and it just works. So they've done a good job with like interoperability of the API. So I don't know any companies that have deployed Event Hubs, to be honest. I mean, they usually just go to Confluent Cloud. I mean, the pricing is very similar, and the service and support of Confluent Cloud is great. Again, not advertising for them. I'm just, from a success perspective, people who've been super successful with Kafka have just used Confluent Cloud because managing Kafka is horrible. So streams are definitely super useful. I've given some use cases of why you might use those, so hopefully that is certainly helpful. So that's kind of like the difference between queues and streams. I wanted to leave about 10 minutes. I have like 15 minutes left for questions because these hour-long sessions are awesome. Usually they're like 45 minutes. So does anyone have any questions? I believe we have a mic here. You can certainly come. Oh, right, yeah, or we can just run it to you. Lights up. Anyone. And you can also ask about mass transit if you want to, but not support questions. We'll do that later.
I don't get it.
This is my daughter. She's the one who made all my slides pretty, by the way. So any feedback on the slides, go through. Yeah, over here.
As a probably alternative to the patterns which you presented, there is some popularity for actor-based frameworks. So how would you sort of differentiate when does it make sense to go in favor of actor model versus using products like mass transit and service bus and others?
Okay, so the question is, why would I use, you have the messaging patterns I talked, which are basically public subscribe and then send receive. When would you consider using something like an actor model? An actor model can include like Akka.net, Akka, Orleans is kind of an actor framework. I actually wrote an actor framework in 2011, and I was going to compete with Akka.net and the others. And Akka.net definitely had the space pretty much defined, and Akka especially for Java. Actors are weird in that you consume a message and you change state. And for me, every customer I've worked with needs durability. So I focused on building state machine sagas and sagas because they're durable, they're transactional, and I can handle events from anywhere. And actors were very niche. I mean, I know that they use them for like a lot of the Xbox gaming frameworks and things where does it really matter if your high score table is updated? Probably not. I mean, to the gamer it does because they want, the cred and the fake points, but I've known people using actor model for things like, some cases, high-frequency trading systems where they're like, we're just going to have all this state stored in here and we're building these algorithms that are processing massive amounts of data in memory. I would say if you needed durability, and I think Akka.net has some stateful actors where they were actually persist, but yeah, I mean, actor model to me it seemed, I basically abandoned that approach. It was always edge anyway. I mean, less than 0.1% of the people have probably ever even heard of it or thought of using it. And what I found is that most companies wanted that visibility of like stateful workflows such as state machines or sagas to process data, which are very much, you process an event and you change your behavior. That's the definition of an actor, and that's what a state machine workflow can do. So it's like I did something and I assume a different state, and I'm processing it. So for me, it was just extraneous, and I stopped exploring actors. So but yeah, I mean, that's certainly an option for people who have that use case that fits that scenario. Anyone else? Going once? Going twice? Okay, finally. Okay, any mass transit questions? All the hands go up. No. Well, definitely, I appreciate everybody coming out today. This is my first NDC London. It's really a cool conference. Plus, the location is really awesome. We can see Big Ben through the window. This is my first trip up to the 5th floor, so it's kind of neat. All my socials are up here. You can find them: my LinkedIn, my Twitter, my YouTube channel. As I said, my full-time company now is loosely coupled. We support mass transit. We develop mass transit. So any needs in that area, the content is on the website. There's hundreds of videos on YouTube of how to get started with like messaging and mass transit and all the tools. So if anyone wants to hang after and ask any questions that they were too shy to put in the microphone, that's totally fine as well. If not, thank you, and I'll release you for lunch.